Hello, my name is Ardi and we are going to solve problem 3 from exercises 4.7 from James Stewart book of Calculus Early Transcendental. So the question is, find two positive numbers whose product is 100 and whose sum is a minimum. Okay, maybe let's give the two numbers a name first. Okay, let's name the first number as x. So x is the first number. Okay, and then I will name the second number y. So y is the second number. And remember that both are positive, right? Because the question says that find two positive numbers. So positive numbers mean that x and y both greater than 0. Okay? And then we know from the problem that the product means that we multiply x and y is 100. So we know exactly that x multiplied by y is equal to 100, right? Okay, I think that's good. And now we want to find the sum, which is minimum. Okay, maybe let's put the sum here. So we want the sum that is x plus y. Okay, whenever we want to find the minimum or maximum, we always work with one variables. But here we have two, one x and one y. So we need to make it into one variables. Okay, where can we work with? We know from the problem that x multiplied by y is 100. Okay, and that means that y is equal to 100 divided by x. Because x is a positive number, so this will not be a problem because x is never 0. So we never divide it by 0 here. Okay, so now we can replace this. So we will have s is equal to x plus 100 divided by x. Okay, but then now s only depends on x. We can rewrite this s as a function of x. So we will have sx is equal to x plus 100 divided by x. Okay, I think because we want to use power rule later, I think it is easiest to make it in the power notation. So I will make it like this. So sx is equal to x plus 100 x to the minus 1. Okay, that's good. Now we want to find out the minimum. So what is minimum? So minimum happens when s prime x is equal to 0. Okay, now let's rewrite that. So we want to find out that s prime x is equal to 0. Okay, now let's take the derivative of this function here. We can derive this x easily, which is becomes 1. And then here we can use the power rule. So I will have plus 100 and then multiplied by minus 1. We move it to the front of x. And then so I will have minus x. And then minus 1 minus 1. So I will have minus 2. And all of that will equal to 0. Okay, now let's do some simplification here. Okay, maybe I want to do it here. There is some space here, right? So we will have 1 plus 100. Okay, I think I just multiply that 1 there. So I will have 1 minus 100. And then multiplied by, I can rewrite that as 1 over x squared. And all of that will equal to 0. Okay. And now what can we do? So we can make this into the right hand side. So 1 is equal to 100 divided by x squared. Remember that x is a positive number, so we can multiply both sides by x squared. So we will have x squared on the left hand side, and then on the right hand side we'll have 100 divided by 1. So that is 100. Okay, and so we can get the x is equal to plus minus the square root of 100. And then we will have x is equal to plus minus 10. And so x is equal to 10, or x is equal to minus 10. However, this is less than 0, so we cannot use this value here. So x is less than 0. So we eliminate this answer here. So our value of x is 10. Okay, so now we need to find out what y is. But y, we can substitute this here to this equation here. So we will have y value is equal to 100 divided by the x value, which is 10. And so we will have the y value is 100 divided by 10. Therefore, the two numbers that is the product is 100 and the sum is minimum is y is equal to 10 and x is equal to 10. So this is the answer. So the answer is 10 and 10 for 10 and 10. This is the final answer. Okay, thank you for watching. Please subscribe, like, and support this channel. Thank you for watching. See you in the next video. Bye bye.